Good day, everyone. This is Vincent Tan speaking. This time, I'm going to talk about how the refrigerant flow in the TMV6, and we just combine the heat pump and heat recovery system in the same outdoor unit. There are three parts of this sharing, and I have put the corresponding video linkages at the below description area just for your reference. Moreover, I also provide the correct subtitle. Don't forget to turn it on if you need. Heat pump cycles. This slide, I just put one outdoor unit, connect with three indoor units. This 1, 2, 3. So first, let's focus on the indoor unit. It is very simple, just the heat exchanger with the EXV, only one. But for the outdoor unit, it is very complicated, right? There are so many components. And for the valves, this here, there are three. It is liquid valve, low pressure gas valve, and also the high pressure gas valve. And this is the low pressure check valve. It just connect to here, which is the gas liquid separator. Besides, here is the compressor, oil separator, and there are two four-way valves. And this one is the outdoor heat exchanger. And there are two EXVs for this outdoor unit. And this is the heat sink. The purpose of it is just to absorb the heat from the compressor dry bulb. And this is the subcooler. It's actually the plate heat exchanger. And here is the accumulator, also called receiver. The purpose of it is just to optimize the refrigerant flow amount. Okay, I will show you how the refrigerants flow for your better understanding. So let's say it is in cooling mode, and I also provide how the refrigerant, the status, either it is the high or low pressure, and either it is the gas or liquid status. And let's say there are these two indoor units is calling for cooling. And this one, I make it to be cooling off, including reach the set point, or it is already turned off in standby mode. So from this outdoor unit, the refrigerant how it flow is from the compressor is always the high pressure and temperature gas, and after get through the oil separator, then go to these two four-way valve, and then this one will go. It is cooling mode, so we just turn right and go to the outdoor heat exchanger to release heat. Then it become fully liquid. Then it gets through this fully open heating EXV, these two. Then the target is the indoor unit. And then also it is a cooling mode. So from here, a bypass from here will get through this EXV, and then this part of the refrigerant will become cooler, then absorb heat from this main row, then itself will become the gas, then to the gas liquid separator. Then the main row, which is this part, it become more cooler to increase the subcooler. And then the refrigerant will be metering at the indoor unit EXV here, and then it become low pressure and temperature liquid. Then it gets through the indoor heat exchanger to absorb heat, which is doing cooling, then become gas and flow back to the outdoor unit. Just follow this one, and to here, to the gas liquid separator, then to the compressor. So you can find that when the indoor unit calling for cooling, this corresponding ESV will just open for the metering. And for this cooling off, it will keep fully closed because there's no need for the cooling. It will stop the refrigerant, just like this. And last, you may wondering, how about the refrigerant flow to the four-way valve? Actually, you can find that the other end of the four-way valve is connected with a capillary, which means the refrigerant cannot get through of it. just like this. This slide is the heating mode in heat pump system. I also put this indoor unit 1 and 3 in heating mode, and indoor unit 2 it is heating off, which is reach the set point or original remains off. How the refrigerant flow is from the compressor, the refrigerant will first flow to the indoor unit, as there's no valves to stop it. So it just get into the indoor heat exchanger to make heat exchange. Then itself will just become the liquid and get through the EXVs and go back to the outdoor unit and then to here. Also attention, these two EXV of the indoor unit, it is not for metering. The purpose of this tool is just for adjust the refrigerant flow to make a balance between the on indoor unit. And where to do the metering is always in outdoor unit, this one, and then it become the low pressure and temperature liquid, then absorb heat at the outdoor heat exchanger, then flow back to the void well, then to the gas liquid separator, and the last go back to the compressor. If the outdoor bin is low, then we need to apply the EVI, right? The purpose of it is just to increase the heating performance and also the capacity. How it operates is there is a subcooler here. We just use this one. A partial refrigerant will get through this EXV and also get metering. Then itself will become low temperature, and then it can absorb heat, which is we make itself to become gas. Then we inject this gas to the compressor to higher the performance. And here is another question: how this heating off EXV operate? Just open a little bit, or fully close, or fully open. So the answer is it will just open a little bit. Also, you can find it there's no valves here, so we need to just open a little bit. The purpose for what? Okay, I show you the answer. It is if we fully close this one, you can find it. The refrigerant is still hot, which means it can still release the heat from the indoor unit. This is the indoor unit 2, and sooner or later, more and more refrigerant will condense to become liquid and also accumulated at this heat exchanger. It also will release to the whole refrigerant or the whole system will be not enough refrigerant. And that is the reason why we need to just open a little bit. The purpose is just let the refrigerant or the liquid refrigerant to get through. That's all for this sharing. If you still have any other question or further concerns, please feel free to contact me on my email address. Meanwhile, you can also scan this QR code to access the sharing material. Hasta la próxima. Suerte, ma. Mata konto.